This is 3I/ATLAS, the third interstellar object ever discovered by humanity. And the latest images captured by spacecraft near Mars have finally shown us what this cosmic traveler really looks like up close. Stay with us, because by the end of this video, you'll understand why this discovery is making headlines around the world and what it means for our understanding of the universe. Our story begins on July 1st, 2025, at the Asteroid Terrestrial Impact Last Alert System, or ATLAS telescope, located in Rio Hurtado, Chile. A small dot moving fast, really fast. The astronomers immediately noticed something strange. This object was traveling at an incredible 137,000 miles per hour. To put that in perspective, that's fast enough to travel from New York to Los Angeles in about 80 seconds. But speed alone wasn't what made it special. When they calculated its trajectory, they realized something extraordinary. This object wasn't orbiting our sun. It was just passing through. Its path was hyperbolic, meaning it came from somewhere else in the galaxy and would eventually leave our solar system forever. This was huge. Only twice before in human history have we confirmed an interstellar visitor. The first was Oumuamua in 2017, which looked like a giant space cigar and behaved very strangely. The second was Comet 2I/Borisov in 2019, which appeared more like a typical comet. And now we had number 3I/ATLAS. The astronomy community went into overdrive. Every major telescope on Earth and in space was pointed at this cosmic visitor. NASA's Hubble Space Telescope, the James Webb Space Telescope, ground-based observatories in Chile and Hawaii. Everyone wanted a piece of this discovery. But there was a problem. The comet was still far away, and it was dim. Really dim. Early observations could only tell us so much. Scientists estimated it was somewhere between 1,444 feet and 3.5 miles across. But the exact size was unclear because it was surrounded by a cloud of dust that made it look bigger and brighter than it actually was. What scientists really needed was a closer look, and they were about to get one. Fast forward to October 2025. Here's where our story takes a dramatic turn. As Earth moved away from 3I/ATLAS and the comet approached the Sun, it disappeared behind our star from our perspective. This is one of the most frustrating things in astronomy. Having an incredible object to study, but the Sun is in the way. But remember, we're not just limited to Earth-based observations anymore. We have robots scattered throughout the solar system, and several of them were perfectly positioned to see what we couldn't. On October 3rd, 2025, 3I/ATLAS made its closest approach to Mars, coming within about 30 million kilometers of the red planet. This might sound like a huge distance, and it is, but in space terms, it's actually pretty close. And we had spacecraft there, ready and waiting. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express turned their cameras toward the comet. Now, here's the thing. These cameras were never designed to photograph distant, dim comets. They were built to take detailed pictures of Mars's surface from just a few hundred kilometers away. Asking them to photograph 3I/ATLAS was like using a microscope to look at something across the room. The scientists honestly didn't know if it would even work. Nick Thomas, the lead investigator for one of the cameras, admitted that the comet was somewhere between 10,000 to 100,000 times fainter than what they usually photograph. But they tried anyway, and when the images came back, the scientific community was stunned. The photos released by ESA show a fuzzy white dot moving against the vast expanse of space. To the untrained eye, it might not look like much, but to scientists, these images were like striking gold. For the first time, we could see the comet's coma, the glowing cloud of gas and dust surrounding its nucleus from a different vantage point in space. The coma measured several thousand kilometers across, a massive halo of material being released as the sun's heat and radiation brought the ancient comet to life. You see, when a comet gets close to the sun, something magical happens. The ice on its surface begins to heat up and turn directly from solid ice into gas, a process called sublimation. This gas escapes from the comet's surface, carrying dust particles with it, creating the beautiful coma and eventually a tail that can stretch for millions of kilometers. But what's really fascinating is what's inside that coma. Earlier observations by the James Webb Space Telescope revealed something unexpected. 3I/ATLAS is unusually rich in carbon dioxide. It also contains water ice, water vapor, carbon monoxide, and something called carbonyl sulfide. The Very Large Telescope in Chile detected cyanide gas and even atomic nickel vapor. Now, you might be thinking, isn't that normal for comets? Well, yes and no. Solar system comets have similar compositions, which initially made scientists think that maybe comets everywhere are basically the same. But here's the twist that has everyone talking. If 3I/ATLAS has a composition similar to our solar system's comets, but it formed in a completely different star system, possibly 7 billion years ago, what does that tell us? It suggests that the basic building blocks of planetary systems, the stuff that makes comets, might be universal across the galaxy. Let's talk about how old this thing is, because this is where your mind is really going to be blown. Scientists have analyzed the trajectory of 3I/ATLAS and traced back where it came from. It appears to have originated from either the Milky Way's thin disk or thick disk. The thin disk is where most of the younger stars in our galaxy are found, including our Sun. But if it came from the thick disk, that's where the really old stars hang out. If 3I/ATLAS is from the thick disk, it could be at least 7 billion years old. Let me repeat that. 7 billion years old. Our entire solar system is only about 4.6 billion years old. This means 3I/ATLAS could have been wandering through space for billions of years before our Sun even existed. Imagine the journey this comet has taken. It might have formed when the universe was less than half its current age. It has traveled through regions of space we'll never see, past stars that no longer exist, through gas clouds, and possibly even through other solar systems. For 7 billion years, it drifted in the cosmic ocean, moving at tens of kilometers per second, covering trillions of kilometers. And then, purely by chance, its path happened to intersect with our solar system in 2025, at the exact time when humanity had developed the technology to detect and study it. The odds of this happening are astronomical. In the vastness of space, the fact that we're even having this conversation about 3I/ATLAS is incredibly unlikely. If it had passed through our solar system just a few decades earlier, we might never have known it existed. This is what makes space exploration so urgent. These opportunities don't come around often. We've only confirmed 3 interstellar objects in all of human history, and we're learning something new from each one. As 3I/ATLAS gets closer to the Sun, something incredible is happening. The comet is waking up. Remember those images from Mars? They showed just the beginning. The Sun's heat is increasingly turning the comet's ice into gas, and this process is accelerating. By late October, when 3I/ATLAS reached its closest point to the Sun at about 130 million miles, it was expected to be at its most active. Unfortunately, this is also when it disappeared behind the Sun from Earth's perspective, making it impossible for ground-based telescopes to observe. This is where having spacecraft at different locations in the solar system becomes crucial. ESA's Jupiter Icy Moons Explorer, known as JUICE, observed the comet in November 2025 as it emerged from behind the Sun. This spacecraft had what scientists believe is the best view of 3I/ATLAS in its most active state, with a bright halo around its nucleus and a long tail stretching millions of kilometers behind it. What are scientists learning from watching this activity? Quite a lot, actually. First, the way a comet responds to the Sun's heat tells us about its composition and structure. Is the ice pure or mixed with rock? How porous is the nucleus? These details help us understand not just 3I/ATLAS, but the conditions in the stellar system where it formed billions of years ago. Second, the dust and gas being released are like chemical fingerprints. By analyzing what's coming off the comet, we're essentially doing remote archaeology, studying materials that have been frozen in time for billions of years. It's like opening a time capsule from the early days of our galaxy. Third, and this is crucial for future missions, we're learning how to track and predict the behavior of interstellar objects. This matters because not all interstellar visitors will be harmless comets. Some might be asteroids, and some might even be on collision courses with planets. Understanding how these objects move and behave helps us prepare for future encounters. Some people have speculated that it could be extraterrestrial technology or even an alien spacecraft. Social media has been buzzing with these theories, especially after the mysterious behavior of Oumuamua, the first interstellar object, which accelerated in a way that was hard to explain with just outgassing. Let's be clear, there is absolutely no scientific evidence to support the idea that 3I/ATLAS is artificial. None. Zero. The observations all point to it being a natural comet doing exactly what comets do. Dr. Avi Loeb, a Harvard astrophysicist who has been quite vocal about the possibility of interstellar objects being artificial, even addressed these conspiracy theories. When asked about speculation that NASA might be hiding information about 3I/ATLAS during a government shutdown, he was blunt. The delay is not the signature of extraterrestrial intelligence. It's more a signature of terrestrial stupidity. In other words, sometimes bureaucracy and shutdowns delay data release. But that doesn't mean there's a cover-up. It just means paperwork and government operations don't move as fast as we'd like. That said, the scientific questions surrounding 3I/ATLAS are fascinating enough without needing to invoke aliens. The fact that we're observing an object from another star system, learning about the chemistry of distant parts of our galaxy, and watching billions-year-old ice sublimate in real time? That's incredible all on its own. So where is 3I/ATLAS now, and what's going to happen to it? As of October 2025, the comet has passed its closest approach to the Sun and is now heading back out of the inner solar system. In November 2025, it emerged from behind the Sun and became observable again from Earth, though it's getting dimmer as it moves away. The comet's trajectory will take it past Jupiter in March 2026, and then it will continue its journey out of our solar system, never to return. By the time it crosses the orbit of Neptune, it will be so far away and so faint that even our best telescopes won't be able to see it anymore. And then it will return to the darkness of interstellar space, wandering through the galaxy for who knows how many more billions of years. Maybe in some distant future it will pass through another star system, where alien astronomers might point their telescopes at it and wonder where it came from. But here's the thing. We got lucky with 3I/ATLAS. We detected it when it was still far enough away to study with multiple instruments. We had spacecraft in the right positions to observe it up close. We gathered data from across the electromagnetic spectrum, from visible light to infrared to ultraviolet. The next interstellar visitor might not give us such an opportunity. It might pass through too quickly, or on a trajectory that makes it hard to observe. Or it might simply be too small or dim to detect with our current technology. This is why ESA is preparing the Comet Interceptor mission, scheduled to launch in 2029. This spacecraft won't target a specific comet initially. Instead, it will park itself at a special point in space and wait. When a pristine comet from the distant Oort cloud approaches, or better yet, when another interstellar object enters our solar system, Comet Interceptor will spring into action, adjusting its orbit to intercept and study the visitor up close. For most of human history, we could only study objects that were born in our solar system. The Sun, planets, moons, asteroids, comets, all of them formed from the same primordial cloud of gas and dust about 4.6 billion years ago. They're all siblings, cosmically speaking, but interstellar objects like 3I/ATLAS, They're visitors from completely different families. They formed around different stars in different conditions at different times. They're the only samples we have of other star systems without having to travel light years to get them. If you enjoyed this deep dive into 3I/ATLAS, make sure to hit that like button and subscribe for more space content. Leave a comment below telling me what aspect of this interstellar visitor fascinated you most.